now. Okay, so that really finishes off chapter 1. So let me start chapter 2. So chapter 2, linear equations and inequalities. In one variable. So now we're going to start discussing uh, equations. And I'll give you techniques for solving equations, for solving inequalities. And in this particular chapter, we're going to be talking about linear equations and linear inequalities. And we'll just start out with one variable. So section 2.1, solving linear equations in one variable. So let me give you some properties so that we can solve equations. Recall that an equation is an expression equal to another expression. So first off, let me give you the additive property of equality. And so if we have some equation, let's say A equals B, then I can add the same quantity to both sides of my equation. And this does not change the truth value of the statement. And so if A is equal to B, then A plus C is equal to B plus C. And so we have both A equaling B and A plus C equaling B plus C have identically the same set of solutions. So similarly, um, well, I can state it as a subtraction property. If A equals B, then I can subtract the same quantity from both sides of my equation, and my equation remains invariant. And so A minus C is equal to B minus C. So let's do some examples. Let's say on page 48, let me do, let's say, problem number, ah, oh, I guess let me just, so let me do problem number 1. 3x plus 5 equals 0. So before I actually solve some equations, some linear equations, let's see what type of equations are linear. And so an equation will be linear if the expression is a linear expression in one variable. And so suppose I have 3x plus 5 equaling 0. Well, 3x, this is a linear term because you just have some constant times a variable, and this particular variable is just to the first power plus another constant. So long as you have expressions of these type, this will be a linear expression. It's equal to 0, which is again another linear expression. Therefore, yes, this is a linear equation. Let me look at problem number 3. 3x squared equaling 5. Now, when I look at this, notice that I have an exponent of 2 on the variable. And since I have this exponent on the variable, then this is not a linear equation in x. So this is not a linear equation in the particular variable x. Let me do problem number 7. 5 times 3y plus 2 minus 7y equaling 0. If I look at this particular expression, notice that I just have a constant multiplying a constant times a variable. So this is really just a constant times a variable. A constant times a constant is a constant. And I have minus another constant times variable. So these, once you simplified it, is just some constant times of one variable plus another constant. So this is a linear expression. It equals 0, which again is another linear expression. Therefore, this is a linear equation in the particular variable y. Let me look at problem number 12. Y cubed equals 1. Well, I notice here that my variable has an exponent. And so since my variable here has an exponent, then this is not a linear equation. In the particular variable y. Yes, unless the variable, unless the exponent of the variable is 1 or 0. So yes, every time a variable has an exponent, other than if the exponent was 0 or 1, then it would not be a linear equation. Okay. So now, before I guess I actually use the added property of equality, um, I said that it was invariant because they had the same solutions, but I guess I should actually, we went over solutions before, but let me do it again. Let's say, let's do problem number 16, which says 4x equal 1, and it says to check if x equaling 4 is a solution. In exercises 13 through 22, identify whether or not the given number is a solution to the equation. So a value for your variable will be a solution to a given equation if you replace every instant of that variable by that particular value. And once you've done that, if the resulting expression is a true expression, then it is a solution. Otherwise, if it's a false statement, then it is not a solution. So let's check. Is 4 times x, when x is 4, equal to 1? Well, 4 times 4 is 16, and 16 is not 1. Therefore, no, x equaling 4 is not a solution to this particular equation. Let me do problem number 24. X minus 3 equals 7. Okay, so let me try to solve this equation. And so to solve this equation, I'll use the additive property of equality, which says that I can add the same quantity to both sides of my equation, in this case 3, and I'll not change the equation. It'll remain invariant. I'll not change the true statement of the equation. And so x minus 3 plus 3, well, 3's cancel. You just get x equals 7 plus 3 is 10. And so x equaling 10 is a solution to our equation. Let me do problem number 34. X plus 8 equals 20. And so let me subtract 8 from both sides of my equation. So by the additive property of equality, I have that x is equal to, well, the 8's cancel. 20 minus 8 is 12. So x is equal to 12. What you notice in both of these situations is that I took the term that was, I looked at the side of the equation that had my variable. I then tried to solve my equation for that variable by either adding or subtracting that constant term to both sides of my equation, and whatever constant term was on the side of the equation that I wanted to clear, I took the opposite operation. So if there was a subtraction, I added 3. If there was an addition, I subtracted 8. Let me do problem number 42. X plus 16 equals negative 28. So notice I have an x on one side of my equation. So to isolate this x on one side of my equation and to, well, solve for this variable, I will subtract 16 from both sides of my equation. Since I'm adding the 16 to x, the opposite operation is subtraction. So I'll subtract 16 from both sides of my equation. So if I do that, I get that x, notice the 16's cancel, is equal to a negative 44. And that is my solution. Let me do problem number, let's say 62. X plus 19.2 is equal to a negative 5.9. Let me subtract 19.2 from both sides of my equation. And so the 19.2's cancel. So I get x is equal to, I have here a negative 5.9 minus 19.2. And so these are both the same sign. I'm subtracting. Well, adding. Therefore, I will add their absolute values and keep the mutual sign, negative. 9 plus 2 is 11. Carry the 1. 20 plus 5 is 25. And so x is equal to a negative 25.1. Okay, so in addition to the additive property of equality, we also have the multiplicative property of equality. And so if I have some equation, let's say A equals B, and suppose that the constant I'm going to multiply both sides of my equation by is non-zero, then if I multiply both sides of my equation by the same non-zero constant, then this equation remains invariant. Similarly, if I have an equation, A equal B, I can divide both sides of my equation by the same non-zero constant, C, and this equation remains invariant. So let me do some further examples. Let's say problem number 78. Negative 10x equals positive 20. Okay, so in this case, I want to solve here for x. So notice that I'm multiplying by negative 10. Since I'm multiplying, I want to get rid of that negative 10. The way I can get rid of that negative 10 is by doing the opposite operation. The opposite of multiplication is division. So I can divide both sides of my equation by negative 10. Positive divided by negative is negative. 20 divided by 10 is 2. Question. Oh, oh, you're about to ask that. Okay, yes, okay. Okay then. Let me do problem number 82. Negative 12 x equals 27. So I'm multiplying the x by a negative 12, and so I want to solve for x. So I want to do the opposite operation. The opposite operation of multiplication is division. So let me divide both sides of my equation by negative 12. So negative 12's cancel. So x is equal to positive divided by negative is negative 27 over 12. But of course, we do not like fractions that are not simplified to lowest terms. So let's try to simplify this. So notice that I can divide both 27 and 12 by 3. So let's divide each of these by 3. And so 27 divided by 3 is 9. 12 divided by 3 is 4. And that is your answer. Okay, close enough. And that is your answer. Okay. Let me do problem number 85. 3x minus 6 equals 0. Okay, so now the first thing that I want to do is isolate my variable on one side of my equation. And so I notice here I have a 3x, but I also have a minus 6. And so to isolate this variable, I want to bring this negative 6 to the other side of my equation. And so let's do that. Well, I wanted to bring the 6 to the other side, just like in the previous thing. I can do the opposite operation. Since I'm subtracting 6, I will add 6. So let's add 6 to both sides of my equation. So I get here 3x equals 6 by the additive property of equality. Now let's use the multiplicative property of equality. And so I'm multiplying x by 3. So in order to solve for x, I want to get rid of that 3. And so let's use the opposite operation. The opposite operation of multiplication is division. So let's divide both sides of my equation by 3. And so x is equal to 6 divided by 3 is 2. And that is my answer. Any questions about that? Let me do problem number 102. (24x plus 36 equals 0). So again, I want to isolate x on one side of my equation. And so let me subtract 36 from both sides of my equation. And so I get 24x equals negative 36 by the additive property of equality. Let me try to solve for x. So let me divide both sides of my equation by 24. And so x is equal to negative divided by positive negative. I can divide both 36 and 24 by 12. So let's do that. 36 divided by 24 is 3. 24 divided by 12 is 2. I think I said it wrong. 36 divided by 12 is 3. 24 divided by 12 is 2. And so I have that x is equal to a negative 3/2. Okay, so let me do problem 121. Negative 10x plus 16 equals negative 12. In exercises 103 to 146, solve the equation of the type ax plus b equals c. Well, we're going to do the exact same thing. I want to isolate x on one side of my equation. So in this case, I want to bring the 16 on the other side of the equation. So let me subtract 16 from both sides of my equation. So I get negative 10x equals negative 28. I want to solve for x, so let me divide both sides of my equation by negative 10. And so x is equal to negative divided by negative is positive. I can divide both 28 and 10 by 2. So let's divide by 2. 28 divided by 2 is 14. 10 divided by 2 is 5. So x is equal to 14 over 5. Let's do problem number 146. 146. 9x plus 2x equals 14 minus 8. 9x plus 2x is 11x. 14 minus 8 is 6. Divide both sides of my equation by 11 to solve for x. So x is equal to 6 over 11. And that is your answer. Let me do problem number 150. Negative 5 times the quantity x plus 3. Oh, oh, that's right. It actually ends at 12:45, but obviously you can end. You can, sorry about that. It was, yeah. So you can leave because it was actually supposed to be 12:45. That was my error. Okay. This was for the captioner. Okay. Accept my apologies. Bye bye. Yeah. Okay. Goodbye. Um. So, negative 5 x plus 3 plus 7x equals negative 7. Okay, so in exercises 147 to 160, use the distributive property to solve the equation. So let me multiply the negative 5 inside the parentheses. Okay. And so I get negative 5x minus 15 plus 7x equals negative 7. And so 7x minus 5x is 2x. Let me add 15 to both sides of my equation. And so I have that 2x is equal to 15 minus 7 is 8. Let's solve for x. So by the multiplicative property of equality, let me divide both sides of my equation by 2. So x is equal to 8 divided by 2, 4. Any questions about that? Let me do something involving fractions. Uh, let me do problem number 157. One seventh, 14x minus 11 minus 3x equals 3 over 7. Let me multiply the 1/7 inside the parentheses. Well, 14 divided by 7 is 2. Positive times negative is a negative. 11 times 1 over 7 is 11 over 7 minus 3x equals 3 over 7. Let me combine like terms. 2x minus 3x is a minus 1x. Let me add 11 over 7 to both sides of my equation. And so if I do that, I get negative x equals 3 over 7 plus 7 plus 11 over 7. Well, 3 plus 11 is 14 over 7. 14 divided by 7 is 2. And so let me solve for x. So let me divide both sides of my equation by, well, if you remember, um, the numerical coefficient of negative x is a negative 1. So let me divide both sides of my equation by negative 1. That's the coefficient multiplying x. Negative x divided by negative 1 is just x. Positive divided by negative is negative. So x is equal to a negative 2. Let me do problem number 162. In exercises 161 to 180, solve the equation. And so, let me first simplify each side of the equation. And so let me multiply the 3 inside the parentheses. So by the distributive property, I have 2 plus 3 times x is 3x. 3 times 4 is 12 equals x minus 3. Let me combine like terms. 2 plus 12 is 14. And now let me, the first thing I notice is that I have x's on both sides of my equation. And so the first thing I want to do is get x's only to one side of my equation. So I want to use the additive property of equality to bring one of the x's over to the other side. In this case, I have a 3 in front of the x and a 1 in front of the x. And so I'll bring the term that has a smaller value, smaller numerical coefficient, to the other side of the equation. Ooh. Where can I find the rules for, and so for this, these are signed rules. So those would be called sign rules. So signed, probably signed rules. And it'll say for addition, multiplication, blah, blah. Okay. So it has rules for signed numbers. So it could also say signed numbers. Okay. And if need be, I can always, on Tuesday or whatever, write them all up on the board if there are any ones that you don't know of. Okay, so let me try to isolate x on one side of my equation. So I look here and there's a 1x and a 3x. So I want to bring everything over to the side that has the larger numerical coefficient, 3x. So let's subtract 1x from both sides of my equation. The reason for doing that is that if I subtract the smaller number, the smaller coefficient from the larger coefficient, then my answer will always be a positive constant coefficient times my variable. And that will be important not for equations, but for inequalities in the latter part of this chapter. And so 3x minus x is 2x. And the x's cancel, so negative 3. Let me try to solve for isolate x on one side of my equation. So let's subtract 14 from both sides of my equation. And so I get 2x is equal to, well, the 14's cancel. Negative 3 minus 14 is negative 17. And lastly, let me try to solve for x. So let me divide both sides of my equation by 2. And so x is equal to negative 17 over 2. Let me do problem number 170. Eight negative 2z plus 5 minus, no, equals 7 2 plus z plus 3 z minus 1. Okay, so let me solve this equation. So first, let me multiply 8 inside the parentheses. Oops. $157. Oh, okay. So let me see. Another division one. Okay. Another one fractions. Yes, I'll do that. So let me finish this and then I'll do it one with fractions. Um, okay. Remind me after I finish this guy. Okay, so let's multiply by 7 and by 3. Okay. Okay, so positive times negative is negative. 8 times 2z is a negative 16z. 8 times 5 is 40. 7 times 2 is 14. 7 times z is 7z. 3 times z is 3z. 3 times negative 1 is a negative 3. So we have negative 16z plus 40 equals 7z plus 3z is 10z. 14 minus 3 is 11. Let me add 16z to both sides of my equation in order to isolate z on one side of my equation. So I get 40 is equal to 26z plus 11. Let me subtract 11 from both sides of my equation. So I get 29 equals 26z. Let me divide both sides of my equation by 26. And so I get that 26 over 9 is equal to z. So 29 over 26 is z. And that's your answer. Any questions about that one? Let me do, let's see, what one did we do? Let's see, we did with fractions was 157. So how about 160? Oh, well, how can you reduce 29 and 26? They're no common. So you can't reduce it. It's already in lowest terms. So there's no way to reduce 26 over 29. Um, it's already in lowest terms. Okay. So let's do problem 160. 3/4 negative 2x plus 3 plus 7/2 x equals 11/4. Let me multiply negative 3/4 inside the parentheses. Positive times negative is negative. 4 divided by 2 is 2. So 3/2 x. 3/4 times 3. 3 times 3 is 9. Plus 7/2 x. Okay. 7/2 x minus 3/4 x. 7 minus 3 is 4. 4/2 is just 2x. subtract 9/4 from both sides of your equation. And so 2x is equal to 11/4 minus 9/4 is 2/4. And well, I can reduce 2/4 to, well, I can divide both 2 and 4 by 2. So this is -1/2. Well, I can, let's do this way. I can get rid of that fraction. I can multiply both sides of my equation by 2. And so by the multiplicative property of equality, I get that 4x is equal to -1. Divide both sides of my equation by 4. So x is equal to -1/4. Why is it negative? Stupid. Thank you. Well, it's negative because I was wrong. That was an easy answer because I'm just plain wrong. Okay, that was a stupid error on my part. Um, I made an error. Okay. Okay, so it's 2/4. Oops. 2/4. Sorry about that. Okay. Does that answer your question? Why it's negative? Because it's not. Okay. Um, so x is equal to a positive 1/4. Okay. Hopefully I won't make any more errors. Okay. Okay. Let me do yes question. How'd you get the 1/4? Oh. Um, I did the multiplicative property of equality. So I multiplied both sides of my equation by 2. 2 times 2 is 4. So that's a 4x. The 2's cancel. So 2 times a half is just 1. Then I divided both sides of my equation by 4. Okay. Or you could have multiplied both sides of your equation, this equation here, by half. And a half times a half is 1/4. Okay. Another way to do this, well, let's do another problem, but I'll show you another way of doing this. Say problem number 158. -3/4 8x minus 3 plus 7x equals -3/4. Another way of doing this is to get rid of all the fractions. Okay, so I could just, well, let me do this first. Let me multiply the 3/4 inside the parentheses first. And so I get here, well, -3 times 8 is 24 over 4x. Negative times negative is a positive. 9 over 4 plus 7x equals -3/4. So what I could do is just multiply every term here by the least common denominator. Least common denominator here is 4. And so if I do that, well, the 4's cancel, so I get a negative 24x. The 4's cancel, so I get 9. 4 times 7x is 28x. The 4's cancel, so I get negative 3. And now you don't have any fractions to deal with. So one way to deal with fractions is just to get rid of them. This is as long as you have an equation, because I can use the multiplicative property of equality. Yes, it is usually better for students, especially students that do not like fractions. And so this just gets rid of them. 28x minus 24x is 4x. Subtract 9 from both sides of your equation. So 4x is equal to negative 12. Divide by 4. So x is equal to negative 3. So this is usually the preferred method for students. But remember, you can only use this on equations. And so the reason that this is preferred for most students is that students don't like fractions. So this just automatically gets rid of the fractions, and you don't have to worry about them until possibly the end. So I will probably be using this technique mostly, just because students don't like fractions that much. So I'll usually just get rid of the fractions at the beginning. I'll clear fractions out. Okay, let me do problem number 180, because I think we were at 160. Yeah, 180, let's say. Oh, wait. We're 170, yeah. So 180. Negative 2 x minus 6 equals negative 5 x minus 4. So let me multiply the negative 2 inside the parentheses, negative 5 inside the parentheses. So I get a negative 2x. Negative and negative become a positive 12 equals negative 5 times x, negative 5x. Negative times negative becomes a positive 20. Now let me try to isolate x on one side of my equation. So the smaller coefficient is a negative 5 in front of the x. So let's add 5x to both sides of my equation. So if I do that, I get 5x minus 2x is 3x plus 12 equals 20. The 5x's cancel. Subtract 12 from both sides of my equation. And so I get that 3x is equal to 8. Lastly, let me divide both sides of my equation by 3 to solve for x. And so x is equal to 8/3. And that is your answer. Let me do problem number 186. The sum of two consecutive even numbers is 6. In exercises 181 through 187, translate the statement into an equation and solve for the unknown variable. So let's let x be the smaller even integer, even number. And so it's an even integer, so it's the next consecutive one was x plus 2 is the next consecutive even number, integer. And so I want the sum of these two consecutive even integers to equal 6. Let me get rid of the parentheses. Combine like terms. X plus x is 2x. And now let's solve for x. So let me subtract 2 from both sides of my equation in order to isolate x on one side of my equation. So 2x is equal to 4. So let me divide both sides of my equation by 2. So x is equal to 2. So the sum of two consecutive even integers. Well, the even integers are, let me get rid of that, 2 and 4. So the unknown quantities in this case were 2 and 4. These are two consecutive even integers whose sum is 6. And so that finishes off section 2.1. So that's it for today then. You should look over the other sections on your own. We're not meeting tomorrow. We're going to see how it works without meeting tomorrow or Monday. But if it turns out that people aren't able to do all this stuff on their own, because there's still the tape that I have of all these meetings previously, and I'm going to tape some more stuff on my own that you can listen to. And so I'm going to see how it works where you just listen on your own at your own pace. And then see if we can continue this on Tuesday. And I think we're going to be on section 2.6 on Tuesday. So I guess I'll see you guys on Tuesday and continue with all those sections from the syllabus that you have to look at over this weekend. Okay. If there are no other questions, then that's it for today. Let me. Where's my? Here it is. My recorder. There it is.